In this video, we review how to use the calculator the chi-square test. This can be used for either test for association / independence or for the homogeneity. Now, those are two different tests. When you write them up, the wording is going to be different, but the mechanics on the calculator are identical. To do these, we actually have to use matrix. So notice the word matrix is in blue, so that. And we're going to edit matrix A. Now, let's assume it's a 2 by 3 matrix. 2 is the number of columns, and 3 is the number of rows. So rows are down, columns across. We only enter where we're going to enter actual values. We don't include any columns, rows where you would calculate totals. So I just made some numbers up here to fill on the table. The matrix. From here, we can go actually directly to the chi-square test. Sorry about that. Chi-square test. Observed or expected is B. If you're doing this by hand, you'd have to calculate the expected counts table yourself. But the calculator would automatically once you run this test, not before you run the test, but after you run it. I'm actually going to go down to draw so we can see what it looks like. So in our situation, the chi-square score is 1.19. The p-value is 0.55. That's well above any alpha we would select. So we would fail to reject the null hypothesis. Last thing we'll do is I want to show you what the expected counts would look like. So notice now matrix B has been populated. We're going to matrix B and see what that looks like. These are the expected counts if there was no association, if there was independence between the two. We didn't have enough evidence that our actual counts were significantly different from this essentially null hypothesis. So that's why we would fail to reject the null.